Starting with the name of Allah, who is the most merciful and beneficent. Today, I'm going to present RSA implementation in Python. My name is Muhammad Tamur Khan, and my role number is 20BSCS045. First of all, we've imported some libraries named random and math for our implementation and the usage. Then I have defined a function called isPrime function, which takes a number as an input as a parameter and then checks if the number is prime or not. Like it returns false if the number is less than 2 or if it's divisible by any number from 2 to the half of the number, which is also called integer division. After this, I define a function called generate prime, which generates a prime number within a range provided, which are the minimum value and the maximum value is the range here. It repeatedly generates a prime number. Sorry, it repeatedly generates a number until it gets a prime number. After that, I have also I defined a function called inverse to get the modular multiplicative inverse of e modulo 5. With this function calculates the multiplicative inverse of e modulo 5. It iterates through the possible values of d. It iterates through the possible value of d from 3 to 5 and checks if d into e divisible by 5 is equal to 1. If no inverse is found, then it raises a value error and prompts a message saying modular inverse does not exist. This segment now after that with this segment generates two prime number from the ranges 1000 to 50,000, which are then stored in the variable p and q. Just to make sure that P and Q are not the same number, we we are using a while loop here to generate another prime number for Q if P and Q are equal. And then we are calculating the value of n and phi of n here. N is calculated by P into Q and phi of n is calculated as P minus 1 into Q minus 1. These are used to generate public and private keys. Um, and then we are generated the public key here, which is stored in the variable e, which this part generates a three. This part generates a number between 3 and t to the phi of n minus 1. It's for such that e and phi of n are coprime, meaning they have the greatest common divisor of 1. So this is used to create the public key here. And then after that, I have generated the private key as well, which is stored in a variable t here, which is generated by using the modular multiplicative inverse function I have defined above, using the parameters of public key and the phi of n here, resulting in the private key, which is stored in the variable d. After all of this, the program asks you to enter your message which you want to encrypt, and then it generates a prime number for P, prime number for Q, a public key, a private key, the value of n and the value of phi of n. Now this is where the magic happens. The user inputs a message which is stored in a variable called message, and then we use that to convert to ASCII values and then store in the variable message encoded. Now the ASCII values are for each of the character in the message. Now encryption happens here, um, where each character's ASCII value is encrypted using the public key E and modulus N to produce a ciphertext, which is stored in the variable called ciphertext. After this, I have also implemented the RSA decryption. The ciphertext is decrypted using the private key D and modulus N, which you can see here, in the decoded ASCII values, and then it stores the decoded ASCII values in the variable decode message. And then we are also printing the decoded ASCII values here, and then we are converting these ASCII values back to the characters and then joining it with a blank string, and then storing it with in the variable called message, and then we are printing the message decrypted here as well. This is the whole code for the RSA encryption and decryption implemented in Python language. Now we move forward to the output of this whole code. Now it's time for to check our program of RSA encryption and decryption. We will going to run this program RSA encryption.py. So here it is asking me to enter a message which I want to encrypt. So let's say hello, my name is Tamo. See, the whole thing has happened here, which the prime number is generated for piece 21,011, and the prime number generated for the Q is 31,033. Where the public key is this and the private key is this, and the value of n is this, and the value of phi of n is this. Now my message before the encryption in ASCII code was this: 72, 101, 108, 111, 32, 109, 121, like this. This whole is the not the encrypted code of my message. Now after that, my message hello, my name is Tamur is encrypted as this. You can see now if anyone wants to crack, he has no idea how this whole ASCII code here are calculated. And after that, I have used, like I showed you it in the code, I have used the private key and the value of n and the value of e to to decrypt my encoded ASCII code message to the original ASCII code message. Like you can check the 72 here is 72 here, 101 here is 101 here, 108 is 108 is same, like all of this same. Yeah, and also it is calculating back the ASCII code to the original message, which was hello, my name is Tamil. Now this is a very basic implementation of RSA encryption and decryption in Python. I hope you like it, and if you have any query, you can ask. Thank you for listening to my presentation. and my code. Allah Hafiz. Take care.